hot, cold, cold. And my kids keep getting sick, and I kind of feel like I'm starting to come down with something. So,
oh, no.
Anyways.
Well, we're just cold. There's no hot involved. It's just cold.
It's hot. It's more like just warming up and then getting really cold. You know, it's like back and forth.
Yeah.
I'm looking forward to a warm up.
Yeah. How'd y'all do last year?
Well, let's just jump right in then.
Yeah.
Let's see. Okay.
I think the further I got along, the more confused. Like number 6, my p-value was off from the.
Okay, you're talking about part 2?
Yeah, part 2.
Okay, that's good. Part 2. Okay, so they give us a bunch of numbers for this realtor guy again, right?
Yeah.
We did this before, and we already said that it didn't change, so, but we got to see it. Okay. So the number 1 is what are the requirements for creating a 95% confidence T interval? So the requirements.
A random.
Yeah, it has to be a random population.
And normally distributed. Or,
yeah.
Distributed.
Or it's greater than 30.
Yeah. Right.
So which means it's normally distributed forcefully. However, okay.
Okay.
So, and then this one. This is the one. Okay. It gives us the t-value right there in the. But if I try to work out the t-value with the numbers they give us, then I get the minus 0.11847, which is what we get for 6b when we compute the t-value.
Oh yeah, that's what I got too. Yeah.
And so when I use the number they gave me, then I get it. Or if I put it in the software, then I get it.
Yeah, that's how I could get it. Put it in the software. But I wonder if we have, like, if are we going to be able to always use our software? Because I thought I was listening to like that brother Kermar or whatever, and he was like, you're just gonna use software for this. I mean, I think he showed like how you could figure it out on your own, but I think on the T-scores he was saying that pretty much we're going to be using SBS. That was kind of figured. But I don't know why they're having us do it both ways, maybe just to try to do it, but I could never get it either, so.
Okay, because when I figured out the T-score, it was the minus 0.11847.
Yeah.
So.
I just did it on the SBS. Have you?
I haven't even attempted opening it right now just because my computer won't let me go into iLearn a normal way.
Okay.
There's some weird stuff going on here with the school website.
Oh, yeah.
So I had to go in through a back way to get to iLearn.
Okay. All right.
Just take notes, I guess. And then you
That's
can
about it.
catch up. So that for number 2, then if you go through, I did this yesterday, but if you go in SPSS and do the descriptive statistics and go there that way to find, let's see, T-score. Analyze, compare means one sample T, and then to get the confidence level, you have to leave the test value blank.
Right.
Right? Did you get that, Sarah?
Mm-hmm.
And then the level of confidence is usually 95% in the software already, so it was already that way. And so then you come up with these two numbers, 41.845 to 51.621.
Right, that's what I got. Mm-hmm.
Okay.
And then the next one I did the same thing, but I put 99%.
Yeah, you have to put 99 instead, and you get a wider range of numbers.
Right. Okay, so when I took the little homework quiz on my own this week, I did all right. I got like a B on it, but you can't see what you missed till like Sunday, isn't it like Sunday or something? I don't know.
Yeah.
So I don't know what I missed, but I was really like there was a lot of those questions like where it said, "Have you all taken it yet? Have you taken
No.
chapter 10 one? No. Okay. Oh, well, maybe discuss it with you. But well, I'm not gonna. I don't know what I got wrong anyway. So, but it's talking about like how if the range is if the what do you call it, the confidence interval say is like 99%, then the margin of error would be less, right? Because it would only be like that 1% margin of error. That's just how I'm thinking of it, like on that applet. Like because you want to get to like 100%. So isn't the margin of error like so the confidence level is like you're 99% confident that this whatever your sample is correct, but you have that 1% margin of error, and say like if you have a 95% confidence level, then you have a 5%. Am I thinking of that right, or is that wrong?
That sounds right, but I don't have that written down.
There's a lot of questions about that. I don't know. And then like so like if it was 90%, you're like the confidence levels are like the 90%. He said that the ones that we usually use are 90%, 95, and
Okay, a confidence level describes the process of creating an interval that predicts the mean, which is unknown, of all possible will contain. This does not mean the probability of containing the interval capture. I didn't spell that right. Captured it or it did not. The probability of capturing is 0 or 1. Was that what they were asking, the probability, or no?
like I'm just thinking of like I'm like just trying to like I think what they're trying to do now with a lot of these quizzes, and you'll start like noticing I think when you take this one, is they're wanting us to really understand the whole concept of it, not just be able to work out the formula, like understand like what this like the big picture in it all. Like so like if someone's just like if someone scenario of like little scenarios that we practice, like we need to be able to explain it to people,
Right.
like so
Right.
like
And every little part of it too.
right. So like I was trying to like afterwards understand, but you can't see your answers to figure out what you did wrong. So it's like hard to understand, but I guess I'll have to figure it out on Sunday. But to me, I'm like looking at that. I just pictured that applet, like where we have like the 90%, the 95, and the 99% confident. Like you know how bigger the tails.
Yeah.
Like, isn't the margin of error the little places on the ends that are not? I don't know. Like, I don't know.
Well,
Out of my head. If you
okay. How about this sentence? As level of confidence increases, the width of the confidence interval increases. Okay? Like the 99 we just did, it has a wider interval than the 95 because now 99% of the data has to fit in those two numbers. So it's a lower number at the lower end and a bigger number at the upper end. Because 99% of the data has to fit in there now. instead of just 95. So we're squeezing more in there, so it's going to have to include more numbers.
Oh, right. So the higher end would have more and the lower end would have less? Is that what you were saying?
Yes, when it's 99 compared to 95 or 90. If we only have to capture 90% of the data, then it would be even narrower. It would be 42 or 43 and 49 or something. So it would be less than the, how they say it, the, I just don't know how to say, okay, the width of the confidence interval. That's what they call that, the
So
width of the confidence
which
interval.
side is, what is the width? Like, is that the, like, I'm just confused. Like, okay.
That's what they're calling that. Okay, for number 3, it's 39.9 to 53.5. That's the width. And so that got wider than the 41.8 to 51.6 of the problem before of 95. So it got wider. The lower number got lower, and the upper number got higher.
Okay.
And the width increased. That's what they're talking about when the width of the interval increases or decreases. That's what they're talking
So is the 53, like the 53 and the 51, is that the width, and the 41 and the 39 is the sample size?
about. No. That the whole thing is the width. Okay. So, okay, let's take number 2. We want to create 2 numbers, that one on the low end and one on the high end, where 95% of the data is going to fall. We're 95% confident, that's how they call it. We're 95% confident that any mean that we're going to get is going to fall between those 2 numbers. No matter what sample we get, we're 95% confident they're going to fall between the mean of 41.8 and 51.6.
Okay.
And if we want to be more confident on that, those 2 numbers have to get bigger. So we now in 3, we're 99% confident they're going to fall between these 2 numbers. So they got bigger. So 39, or they got wider. The confidence level got wider. So 39.9 at the low end and 53.5 at the top end. But if we wanted a 90%, then they would get even smaller than the numbers on question 2 of 41.8 and 51.6. It would be like 41 or 42 or 43 and maybe 49 on the top end, because now only 90%. We only have to be 90% confident that our mean of any sample we choose is going to fall between those 2 numbers.
Okay. So, but what happens to the sample size? Like, if the sample size gets, like, if you take a larger sample size, like, the larger the sample size is it the higher the confidence level would be? Because I think that was one of the questions. I don't know.
Let's see. Okay, there's just a second. Let me look at what I wrote down for sample size. What's sample size? As the sample size increases, the width of the confidence interval decreases. Okay, so yes. So when you get a bigger sample size, then the width decreases. Those 2 numbers get closer together because you are more confident that you're getting the correct mean.
Oh, yeah. See, I was thinking like the bigger the confidence level was, the more confident you were. So it's actually the more confident.
Well, no, they're talking just about sample size. As the sample size increases, you're more likely to get the right mean.
Oh, more accurate, like an accurate.
Yeah, it's more accurate, and so your the width of your, I think call that the confidence interval. The width of that confidence interval can get smaller the bigger your sample size.
Okay, so you're getting closer to like one number versus two. Like they're getting like more like
Yeah, yes.
yeah.
They're getting closer to the
Okay.
mean. The mean in the middle
The meat. And then
of 0. Or like if you're thinking about the applet, they would get, those two lines would get closer together, they would get closer to the mean of 0.
okay. And then if the confidence level, so if it's like the level like 90, 99, 90, 90, 95, 99 increases, the width gets bigger.
Right.
And then if the sample size increases, it gets closer together.
Smaller. Right.
Okay. And then there was
Because it's more accurate. The more sample size you have, the more accurate your numbers will be.
so then it also throws in the whole margin of error. Like we have to understand how the margin of error, like what happens to that? Does that get like see like number 5? How does the margin of error 95 confidence interval compare to the 99 interval?
Margin. Yeah, that's the same thing we've been talking about. Those two numbers.
Okay.
For 95, it's the same thing. That's what they're trying to practice.
The margin of error, what is that? Is
The
that
margin of error is it's that part of our equation, t times s over the square root of n. That's the margin of error, right? Is that right, Kelsey?
Yeah, that's right. Like I understand the formula of it. I'm just trying to think of it as in terms of like how we're looking at the applet, like how we just the width and the
Well, see, that's
confidence.
what those two numbers are, I guess. I mean,
Like as far as like the confidence level, where does that fit in? Is that like the part that is on the outside of the applet? Is that those like not in the middle? Because that's like they're starting to ask us questions like that. That's what I was like, whoa, I don't understand. Like, but they want.
Well, for this, I don't know. For this, we're not using the applet. I don't know how the applet.
Okay, not the applet, but like as far as like a statistic goes, like what would be the margin of error? Is that the part that's outside of the confidence level, or in it? Is it in it or out of it? Is it like the
error for the confidence level is small.
Is it like the 5%? Like if we're 95% confident, is it the 5% that we're not confident?
Yeah, I think you're right.
And then if it's like,
isn't that how they asked us last time? Our last thing says okay. I think we had a question like that last time where they said the margin of error was 5%, right? So it was a 95%.
well, and then if it's like 99%, it would be the 1%. And then if it was, but wasn't it like we used decimal, like it was like the 0.05 for the 5%, and then the 0.01 for the 1%, and then for the 90% it would be 0.10 for 10%, like margin of error. I don't know. I think we just have to understand that somehow too, and it's hard.
That was lesson 10.
Right, and that's what your quiz, when y'all take it this weekend or whenever you're taking it, it'll go over that. Like, and I was just like, oh, I forgot about all that. Like, I wasn't understanding some of the questions they were asking. I was like I can do the formulas, and I know what the margin of error formula is, like how to find it. You just like they want us to understand how it all relates to statistics now, and I'm.
The margin of error gets smaller as the level of confidence grows smaller. So, So this question we had last time, the BYUI professor would like to repeat the experiment. He wants to make sure he has enough students for a sample to ensure that his margin of error is 5. How many students will he need to be in his sample to ensure that he has the level accuracy of 95 confidence interval? So yeah, you're right about that. It's the margin of error is 5.
5.
And so the level of accuracy is 95.
So I wonder if when the if we're talking about how the level of confidence gets small or bigger as the numbers. Okay, so if we go from 90 to 99, the level of confidence gets bigger, right?
Yes. Yeah, that's what you're talking about. 90. Yeah.
So if our level of confidence gets bigger from 90 to 99, what happens to our margin of error? Does it get
margin of error gets bigger as the level of confidence grows bigger. Because it says if it gets smaller, the level of confidence grows smaller.
So the margin of error gets bigger?
If it gets bigger, then it gets bigger.
Seems like if it was
the margin of error gets as the level of confidence. Okay, it says the answer to one last time says the margin of error gets smaller as the level of confidence grows smaller.
Really? Well.
It says, okay, remember the margin of, I wrote this down from the book, I think. Remember the margin of error is just the second part of the equation of z times sigma over square root of n. Therefore, in comparing the two margins of error, the margin of error for the 95% confidence interval is 8.87, while the margin of error for the 90% confidence level is 7.47. So for the 90, the margin of error was less than the 95.
That seems so backwards to me.
Yeah, it does seem backwards, but that's what it's saying.
All right, so the margin of error gets bigger.
It does. I see how you're saying it seems backwards because yeah, it does seem backwards. I'll have to look at that.
Okay, you were saying in your book it says, or in the book it says the margin of error gets bigger as the.
Well, okay. Well, I'm gonna have to look at that. And
yeah,
see.
I don't know. You guys can do that
because it's not really. I see how it's confusing.
Yeah, because it seems like it would get smaller. Like it would go from a 10% margin of error to a 1%. Like I don't know.
Right. And so it should get smaller.
But I think that's what I missed. I think that's the things I missed on the quiz. So if you guys figure it out, I'll do my quiz on Sunday, and then I can just look at it then. But
did you guys go over your test with her? Because I forgot to email her about that.
I haven't, but I really need to. I just have not had time because I think I made stupid mistakes, basically, I'm sure. So, because I felt like I understood a lot of it. It was just probably, I don't know, moving decimals the wrong way. I don't know, stupid stuff. So, or just not doing the right formula in the right place or something. I don't know. Okay.
So where? Let's see. We talked about.
So, were we on number
4?
Yeah.
This one it says to use the software, so that was easier.
Basically. For those.
So, yeah, just putting in the software. So I got 81.8449 to 51.6218.
Oh, for the
495 for 4A, and then the 99 is 39. I mean, not 81, 41.
That's what I was like. Oh,
I wrote it. Yeah.
I was like,
41 to 51.
Yeah. Okay. And then 39.
And then, 39.9484 to 53.5.
Okay.
Avery?
And then,
And see, as it went from 95 to 99, those levels got wider.
right.
The low number got lower and the higher number got higher. So
Yeah.
now we're 99% confident that our mean of any sample size we're going to get is going to fall in between those two numbers.
Mhm. Mhm. I think I understand the level of confidence, but that little margin of error thing, I'm like,
Yeah, I'm going to have to look at that again because that's
yeah. Okay. And then number 5.
okay. So this is talking about just that thing. How does the margin of error of the 95% confidence level compare to the 99%? Margin of error is,
Smaller. So the 95 is,
the 95.
because the 99 was bigger. The width was bigger, right? Because it got bigger as it increased. So what is the margin of error?
The margin of error.
95 is smaller than 99. I don't know.
So you're less likely. No, I don't know. I'm going to have to read that more. I'm going to read that more because it seems like it should be the opposite
Seems
because
like it should be.
your error rate should go down with a confidence level of 99, but I guess maybe the more confident you are, the more likely you are to make a mistake. If you think of it like that, I don't know.
Or I don't know. Any thoughts on this, Kelsey? While we're talking about it, of how it would make sense, the margin of error would get bigger. It seems like it would get smaller.
Yeah, that's what I was thinking, but
Math is
I don't know.
sometimes.
Yeah.
Okay.
Yeah, I'll have to watch the videos again. He explains it pretty well, Brother Comer, why they was doing this, and read it again and go through it.
Yeah,
It wasn't actually too much stuff, so I can go through it one more time
yeah.
this week, especially since I got to drop that one class.
Oh, yes.
Rather than estimating the age of his clients and buy investment properties, the realtor agent would like to test the claim that the age of his client is different than the national average of 47. Use the 0.05 as your level of significance. Follow the sequence of steps. Okay. The null is that the average age is 47. So HO mean equals 47. So that's the average. That's what the national average is.
Right.
Okay. And then he wants to see if it's different. I guess he's not caring if it's higher or lower. He's just seeing if it's different.
Mm-hmm.
Okay. So that's the slash, the equal slash, and that would be the true-tailed test. And with this stuff this week, with the SPSS, it really mattered whether it was two-tail or one-tail, because then if it was one-tail, you had to divide the sigma thing in half to get the p-score, right? Did you catch that?
Yeah, you had to divide. You divided the standard deviation in two, or the p-score?
No, not the standard deviation. Well, it's the p-score, but it didn't list it on the software as the p-score. The p-score is said the sig. Well,
Oh,
so maybe you are counting that, but it would give us the T, the DF, and the degrees of freedom thing.
yeah.
That's just one less than the sample size. I don't know what I'm really not sure how that goes into anything, this
So if it's
degree of freedom thing. But
yeah,
anyway,
so if it's, I think that the degree of freedom's only for T-scores, like not for the Z, not ever for this.
right. But it's just one less than the sample size, so
Right. Yeah.
I don't really know. Maybe it'll come in more than later, but anyway.
Well,
So
so if the questions asking if it's a two-tailed, not a two-tailed question, then we have to divide it by 2.
Right.
Yeah.
Right. Okay, so this
But
one
if you use
is
Excel, Kelsey, then you don't. But
Okay.
I don't know. But for
but
SBS, I do. I use SBS, so.
Yeah.
so yeah, I haven't used Excel doing this either because I haven't figured out how to do the formulas for it.
Mm-hmm.
So compute the test statistic. So that's what the t equals, and then this is where I got the minus 0.11847, just like I did a couple questions ago. But last time it was wrong, and this time it's right. I don't know.
Yeah,
I don't know.
because I couldn't figure that out.
That's what was confusing me when I was emailing you yesterday. It's like, that's what's confusing me. I don't know how they got that as a question. But, oh, maybe we'll understand it more as we go.
For D, I got, like, I could never figure the P-score, because, like, I got, on SBS it's 0.909, and on the answer key it says 0.907. So,
Yeah, I got 0.9092.
yeah.
In fact, I got, and when you click on it, it expands it, and I got 0.908523. That's as far as it went, because I was trying to figure out how they got 9077. But when I expanded it, it was 0.9085. A little closer, but still not that. So,
Yeah.
anyway, that's what I got.
I don't know. Okay.
So, then F, just like last time, we failed to reject the null hypothesis, so the mean is still 47 years. So. And then present your conclusion in English sentence. Insufficient evidence to conclude the mean age of the realtors, customers who are buying second homes is different than the national average. So, we ready? Let's give it a try.
Welcome 3 Island works with me.
Okay.
Okay. Island doesn't like me.
Group meeting. Is it freezing enough or having trouble, Kelsey?
I'm just going to see if I can log in again, going the back way. Because you know how it expires after you aren't using it for so long?
Oh, yeah.
It did that to me, and I was like, oh, maybe I'll have some luck this time, and I clicked it, and it's like, nope.
Yeah, it does seem like it's acting strange this morning.
Yeah, it was like, it wasn't just going to the school website, it was giving me some weird login thing, and I was like, I'm not logging in. That is not school.
Like someone hacked into it or something, maybe?
Well, I know last night one of our FHE brothers was saying that through his email, that Island was down for us. But I guess it's not for you guys. Maybe it's a different server.
Maybe so. That's terrible. That's like what the whole school runs.
Mm-hmm.
Okay. Tell us when you're there, Kelsey.
Yeah. Hope and pray it works. So far, Google's giving me issues, and it's like, no. Everything else is working fine.
I'll be right back.
Okay. So for I'm not having any luck. I can even go to the back way right now.
Well,
You guys can go ahead and get started, and I'll just write stuff down when I
okay.
get it open.
So number 3, it says in previous lessons we have assumed the population standard deviation was known. In this lesson we are making a different assumption about the standard deviation. What has changed? And we assume it's unknown.
Right. Humans unknown.
Okay. The null hypothesis 8 mu equals 8, and the alternative hypothesis HA mu is greater than 8, and the population standard deviation is not known. He collects a sample of size n equals 9 and computes x bar equals 11 and sample equals 6. Use the information for questions 4 and 5. Is the standard deviation known? No. Nope. Says it's not known.
Okay. And what is the value of t? So that would be that formula. So,
All right, so the formula, Kelsey, is x bar minus mu over s over the over the n square root.
I was able to get that from the video. The video let me play while I had iLearn open.
Okay.
But now I just can't get it open again.
Yes. 11 minus. What is mu? Did they give us mu?
8.
I don't remember.
It's 8.
Oh.
It's 10. It says the.
You're right.
Right?
8. Yes. Okay. Minus 8 over 6.
Size of 9.
Where
S equals 11 and S equals 6.
I took that chapter quiz at the church last night while my kids were at Achievement Days and Young Men's. That might have not been the best idea because my little one kept coming in and out, and I was like, leave me alone.
Yeah. I just think you may have to time your quizzes and tests a little bit better when your kids aren't around.
I know, and that's what my husband tells me all the time. He's like, why do you do? I'm like, you don't understand. Like, there's not ever a good time. Like, like my life is so busy. Like, there's never a good time. Like, I feel like I need to sit down and organize, like, plan it out though better. It's just.
Yeah. They go to school, so it's like.
And it seems like during the day, like I tend to study, and then by the end of and like do other things, and then by the end of the evening, I'm ready to take the quiz or the test. But I need to maybe do it reverse, or I don't know. So.
Wait, I guess you can't take it before you do it. So what did you get for this one? So 11 minus 8 divided by 6 divided by the square root of 9.
Yeah.
Right, so what'd you get?
0.055 or 0.06.
Oh, here, let me try it again.
Okay.
Okay, just to make sure I'm getting numbers, it's 11 minus 8 divided by 6, which is divided by the square root of 9.
Right.
Okay.
Oh, 0.166? Or did I do that? I don't know what I'm doing. 11.
I'm going to try it again. They're easy numbers. So.
Minus 4 root of 9. Yeah, I got 0.16. I don't know.
0.16? I got 1.5.
Yeah, that's what I got too.
Okay, hold on. 11 minus 8. 3.
Mm-hmm.
Divided by 6. $1.5. Yes, I don't know. I did it. different the second time. Okay. 1.5.
1.5. Okay, round 2, 1.1. Okay. Use the following values, which are pulled from the data file body temp. Paste them in the software. I wonder if they're the same as body temp. Okay, here. Let's see. I can copy those. Copy. And body temp.
Are you just opening a new screen on SBS and pasting that in?
Well, I'm opening this body temp one and see if it's the same.
Oh.
I'm going to paste it into, I'm just going to paste it into a different call on that same one to see if they're the same. Just to check. Or I could open a new one and do it that way, but I think okay. Okay, 99. Oh, well, they're not, there's not as many.
Okay.
So we're going to have to take, I'll just take this one. So, okay, so what's it asking? We have to get the T-score. It's to me. So we go to and one T test. One single T test. And let me look at the
I have mine up. Do we need to put the test value in for any reason or not? On that little spot. Like,
okay, let's see, what does it say? Copy and paste this one. HO is 98.6. Oh, and the HA, this is where they're trying to confuse us, is less than 98.6. So we're going to have to divide that. Level of significance is 0.05. So that gives us a 95, which is already there. What is X? And T and P.
So is this a 95% one?
Yeah, well, because A equals 0.05, right? Level of significance is 0.05, so that's 95, right? If I'm thinking right this morning, let's see, body temps. Okay. Options, 95%. Continue. So do we put, it's not asking for a high and a low. It's not asking for the intervals, right? Just a second. So what do I have to put something in that test value? Put in, oh, the null hypothesis goes in the test value. Okay, I'm remembering from yesterday. 98.6.
So for the X bar,
Where'd it go? I lost it. So n equals 21. 93.529 standard deviation. 8. And one sample test. Okay, and the sigma 2 tau is 0.293. Mean difference lower. Okay, that's not right because we didn't put the zero there. Okay, look at that. 9. 0.292866.
What did you get? Like, so what are we putting for X bar? Like that first question, 'cause is that the mean?
2 seconds, divide by 2. Okay, 0.2. Okay, let's see. Got it all written down. Let me go back to this and see. Okay. X bar. Yeah, that's the, let's see. They're making us use our brains here. Okay, the sample mean. And that's what we got, was a sample mean. X bar is a sample mean. So that's 93.54.
I got 98.22, but I don't know why. Did you copy and paste all those in?
Yeah. Here, why don't I'll go back and let me make sure. Okay. Can I read you my numbers and make sure everything's positive?
Mm-hmm.
Oh, why did I have that? I think I have a 0 at the end. Maybe, okay, that might be it.
Oh.
How many do you have?
20. Yeah.
Okay, for some reason it gave me an extra 0. That would probably change my numbers, wouldn't it? Okay, hang on. Let me do it again.
Okay.
Okay, I don't know why it gave me that. Okay, let's try this again. First, let me go back and erase. Okay. Analyze, compare means, sample t-test. And 8.6. Options 95. Okay. Yeah. It's giving me 20 instead. Okay, let me try this again. Okay, yep. Give me all the numbers.
Okay, so
Let me try it again. I'll write them out again. N equals 20. The mean 98.22.
Yeah.
Standard deviation. Boy, just one sample size, even if it was a 0, made that big of a difference.
So do we divide that by 2, the 0, 0, 0, but how's that going to make any difference?
Well, we're going to have to expand it and then divide it because it mattered last time. It mattered a 1,000th point.
So how do you expand it? Because I double clicked on it and I got like 3.3349 to the 40th or something.
Second, 1.843 the df equals 19. There, sigma 2 tau is 0.081. Let me look at it. Okay, so then it says 0.080,964, and it may not make a difference in this
Did
one.
you put your test value as 0?
Did I what?
Did you put the test value as 0 or something else?
The test value says it's minus 1.843.
That's what I did wrong.
So then the p-value then would equal 0.
Wait, what did you put as the test value?
4. I haven't put, I've just been writing these down. I haven't put anything in there yet. Okay, now I'll go back. Now go back and see. Okay, now I'm back to the test, the quiz. Okay, what for number 6, the x bar, which is the sample mean, which was 98.22.
Yeah.
So if you put 98.22, and the S, which is the sample standard deviation, so that's S not O, 0.922.
Yeah. Yeah.
Is that what you got?
0.922. Yeah.
0.922, okay. And the t-score is negative 1.843.
No, I got like 476.407, but I didn't put anything as the test score when I did. That's what I was asking. Did you put something in the test score?
Oh, you had to put in the box the test value. You had to put HO. You had to put the hypothesis of 98.6.
Oh, okay. That's where I went wrong. 98.6. Oh, hold on. 98.
I knew there was something strange about that when I was looking at it. It's like when you're getting the two values of the
Right.
interval, confidence interval, you leave that blank. But when you're doing the hypothesis test, you have to put the hypothesis in there.
Right.
The null hypothesis.
Explain that again? What did you say?
You have to put the null hypothesis in that test value square.
If you're doing
if you're doing the hypothesis test.
But if you're not, you don't?
But if you're getting the confidence interval, then it has to be blank. It has to be 0.
Okay.
Or
so
blank. You could leave it blank or 0, I guess.
So if you're doing a confidence interval, it's blank. If you're doing a hypothesis test, it's the whatever they give you for that.
Yeah, so try it again. Put 98.6 in there. That's the hypothesis.
I got negative 1.843 for the test.
Right. Yeah. Okay.
And then the the DF, I got 90.
Yeah, we don't need to put that in. Yeah, that's just one less than the 20 we have.
All right, and then the two-tailed thing, I got 0.081, but don't we divide that by 2?
Yes. But I expanded it before I divided it because it might make a difference.
Oh.
So anyway, but tell me what you got. There it says round to 3 decimal places.
How do you expand? Because mine isn't really.
I don't know. It takes me a couple clicks sometimes to figure it out. Click it this way, click it that way.
Yeah, I got it. Let's see. 0.
So A equals 0.05. So what did you get for the p-value?
If I didn't expand it, I got 0.0405. If I did expand it, I got 0.040482.
See, yeah, 4. See, I got, yeah, 0.0404, then, so the 4 would not make the 0 a 1, and so that changes. By expanding it, it did change what we got, right? So we should probably expand it, and hopefully that's what we got. So
What would it be?
point
0.040?
040,
Oh.
I think, because, well, that's expanding it. I think if we get it wrong, we can always, email her and say that we got it right. Because
Right. So
I don't
instead
know.
of rounding up to 1, we're just going to leave it 0.040.
Yeah.
Okay.
I don't know. That's I guess.
Yeah. Okay. All right, let me get out of this screen because I can't see my test. Like,
If we don't expand it, then we would get 0.89 divided by 2. 0.041. We get just 1/100th of a difference.
What did he say?
So
What did Brother Cromar say to do on that? I don't remember. He said something about it on one of the videos. Did he say to expand it?
I thought so.
That's what
I
I.
thought that's where I got it from.
Yeah.
But I don't know. I'd have to watch it again to be sure.
All right. So what is number 7? What is S? What do we put for that?
S is the standard deviation that we got from our sample size. So it's 0.922. 0.922.
Is S standard deviation, or I thought
S is the sample standard deviation. So that's our standard deviation from our sample size.
Okay.
So this is what makes the T different. That's what he used when sigma is unknown, then we use S, which is the sample standard deviation instead of the accepted standard deviation of O, because we don't know what it is.
Okay. Got it. Oh my gosh, there's so many rules to remember.
I know. So, number 10, what is the correct decision based on this evidence? Do we fail to reject the null hypothesis? So, so Kelsey, what do you think? The A is 0.05, and our p-value is 0.40. Oh, no, it's 0.040. So.
Did you put for the t-score, what did you put for the t-score? -1.8?
Yeah, -1.843.
Did you put it in as a negative on the answer?
Uh-huh.
Okay. And the p-value you put 0.040.
Yeah, 0.040. Yeah, I had it in there right, but I had it written down right here wrong.
Okay.
0.040.
Okay, and then.
So.
What is the correct decision based on this evidence?
So our level of significance is 0.05.
It is less, so if it's less than it,
the null is low. If the null is low, reject the null.
If P is small, reject the null.
Yes.
Is that it? If P is small,
P is low, reject the null.
Yeah, P.
Right?
Yeah,
Okay.
I just put if P is small, reject the null. So yeah, P is low. Yeah, so we fail. Oh wait.
We reject the null hypothesis?
Yeah. If P is.
It's less than.